Welcome back to a new video. This video is going to be about predicting a word using deep learning. This video is going to be one of the videos that I create for my natural language processing with Python playlist. I will be adding its link in the cards of this video. Let's start coding. Okay, so we are going to create a deep learning model which is going to predict a next word from the sentences that we are going to give. Like, let's say I love New York, and when we say I love, it's going to give New York. That's going to be our case in this video. So I'm going to start by importing the libraries that we are going to use. I'm going to import Torch. We are going to use PyTorch for the deep learning side. I'm going to import torch.neural-network as neural network. And then I'm going to import torch.optimizer as optimizer. And then I'm going to say from torch.autogradient import variable. Great. Not like that, like this. Great. So after that, what I'm going to do is I'm going to say sentences is going to be like a list. I will say the quick brown fox jumps over the lazy dog. It's going to be simple. I'm trying to make the sentences simple. PyTorch is an amazing, and then I will say like framework for deep learning, and I will say like natural language processing is great way to work with text. So it's going to be all. Great. So we are going to tokenize the sentences. So for that I'm going to say words, and it's going to be sentences that split for sentence in sentences. Also it's going to be sentence because we said for sentence like this, and I'm just going to call the words. Great. So after that I'm going to set something like vocab, and it's going to be set word for sentence in words for word in sentences. And when I call the vocab like this, we are going to see great. Here we can see the sentences. Great. Then I'm going to say word to, and then I'm going to say word index for index word in enumerate vocab. Like when I run this, we are going to see that if I call that, we are going to have this 0, 1, 2, 3, 4, 5. We just gave numbers to sentences. So I'm going to convert sentences to index right now. I'm going to say data, and then I'm going to create an empty list. Then I'm going to say for sentence in words, indices is going to be word to index, like word for word in sentence. And then I will say data.append like indices -1 and indices 1. So when I call the data, actually there's a problem, let me quickly check. So we created it like sentences, so it's going to fix the problem, I guess. Yeah, it does. I'm just going to call the data. Here it is. So now I'm going to create a class for defining the model. I will say class next word prediction, and it's going to be neural network.module. We will say define init. We will say self vocab size, embedding dimension, and hidden dimension. And we will say super next word predictor self dot init. After this initialize, we will say self dot embeddings, and it's going to be neural network dot embedding vocab size and embedding dimension like this. And then we are going to say, by the way, it needs to be predictor for matching them. Yeah. And then we will say self dot lstm. We will say neural network dot long short term memory embedding dimension and hidden dimension. And then we will say self.linear. I'm going to add a linear layer like neural network.linear, hidden dimension, and vocab size. And we are going to define a forward method like self and input. And then we will say embeds is going to be self.embeddings input inside of it. And we will say lstm out and underscore self.lstm embeds.view length of the input, and then -1 and -1 like this. And then we will say output is going to be self.linear lstm out.view length of the input and -1. And at the last step we are going to return the output. And after that, actually let me quickly check, we need to put it in the function like this. And great, so here it is. Here is our model. So let's put some hyperparameters like vocab size is going to be length of the vocabulary, and then we will set embedding dimension like 50. We are going to set hidden dimension like 100, and we are going to set learning rate as 0.01. So after that, what I'm going to do is I'm going to say model is going to be next word predictor vocab size, and we will give embedding dimension and hidden dimension like this. And after that, we are going to say loss function is going to be neural network cross entropy loss, and optimizer is going to be optim.sgd model parameters inside of it, and we are going to set the learning rate as LR that we just defined in here. So after running that too, we are ready to train our model. So for that, we are going to say number of epochs, let's say 1000, and then I'm going to say for epoch in range number of epochs, for context target in data, it's going to be our training loop. Context variable is going to be variable. We will say torch.long tensor, and we will give the context, and then we are going to say target variable is going to be variable torch.long tensor target. And after that, we are going to set zero gradients like model.zeroGrad, and then we are going to say output, it's going to be our forward pass. We will say model context variable, and then we are going to say loss is going to be loss function. We will give output and target variable like this, and I'm going to use backward pass like loss.backward, and I will say optimizer.step. Also, we can do something like we can print the loss, like we can say print, like let's say directly, let's print like loss like this. We can say loss, and we can do that. So there's a problem. So the reason of the error that we are getting is on the class definition, we are going to see that I forget this in here. So you need to add this in your forward method, and when I make run all on this Jupyter notebook, we are going to see that it's working smoothly, and we are going to print our loss 1000 times. Like we can see it's going to be lowered like 1.78 to, let's check the below value, it's dropping 1.12. yeah, it really lowered. Like I can come to here, it's still training, we can see it gets lower and lower. Okay, I don't care anymore. I will show you the final value. I'm just going to get to the class part, and I'm just going to show you what I changed. You need to put this in here, so this is important. If you put that, it's going to work smoothly. And let's see our final loss, and I think it's still training. You can just add something like if epoch divided by 100 equals to, let's say, actually we can use modulo instead of this. If epoch modulo 100 equals to 0, then actually 1, then we can print the loss. And you are going to see that it's going to print it less right now. Like it's going to print 2 less values. Like for sure it's not going to print the loss for the 1000 times. Great. Now our final loss is like 0.001, which is a great value, I guess. And now we are going to predict the next words. So let me call our data again from the top. So it was like this. I'm just going to call the sentences again for seeing the raw input we put. And now I'm going to define a function. I'm going to define it in here. I will say define predict next word, and it's going to be context as the input, and we will give like context variable is going to be variable torch.longTensor context, and then we will say output is going to be model context variable like this, and then we will say predicted index is going to be torch.maximum output -1 and 0, and then I'm going to say predicted word is going to be word for word index in word to dot items if index equals to predicted index item, and we will get the 0 from here. So this is going to be our function, and we will return the predicted word in here. So I'm just going to make it run, and then what I'm going to do is I will say test context, and it's going to be like word to index word for word in the quick brown, and we expect the fox after that, and I'm just going to say that split like this. And then what I'm going to do is I'm going to say like predicted word is going to be predict next word function, and we'll pass the test context. Also there's a problem, let me quickly check. Yeah, this is the problem. Okay, now it's cool, and we can just make it run, and we can call the predicted word in here. So it's fox as we expected. Great. So this was the original sentences, and it's working smoothly. We can just change this like we can say PyTorch is an amazing, and we can just try this, and let's see if we get nothing because this is the last word of the sentence. So I'm just going to delete that and make it rerun. So that was my error. We get amazing. Great. Let's see framework for deep. How does this working? Like this. And yeah, learning we get from here. Great. It seems like it's working successfully, but let's test it. Like this time I'm not going to give all of this. I'm just going to give great way to work with. Not great way to work with. I'm just going to give great way to work. So we need output as with, not text. Text is the last word and with is the next word. So I'm just going to call the predicted word in here. I'm just going to make this run, and we are going to get the with. Great. So it's working smoothly. Let's also check this one. Like jumps over the, and let's test our model with the final sentence. Great, we get the dog. So we can just do another thing like natural language processing is, and let's see if we get the is. Great, so it's working smoothly. So that was all for the coding part. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I have a playlist named Natural Language Processing with Python. You can reach to that playlist from the cards of this video. See you in the next tutorial.